Good morning and good afternoon and good evening to everyone who has joined us today. Thank you very much. My name is Yolandi Young and I'm joined with Daniel Villa. He is going to be presenting this webinar today. And the topic for today's webinar is Strategic and Tactical Mine Planning for Block and Sub-Level Caving Projects and Mines. Daniel, if I can ask you to switch on your webcam in the meantime. To those who are on the webinar, please note that we have a dedicated 10 minutes assigned to the Q&A section at the end, allowing you the opportunity to ask questions. So do stay tuned and type in those questions should you have any questions. Daniel, I'll hand it over to you to introduce yourself to everyone that's on the webinar.
Thank you, Jolandi. Well, first of all, thanks so much for being here tonight for me and probably today for you. My name is Daniel Villa. I'm part of the global industry process consulting team for Dassault Systemes, GEOVIA brand. And my role is to work with the digital transformation project for mining industry. My background is a mining engineer. I have more than 20 years of experience, mainly dedicated to mine planning and more specifically to caving. In my previous role, I was the director of the caving business unit, where I have the chance to work with most of the mine and project worldwide. So I had a chance to go around and dedicate a lot of time and effort in block caving and sub-level caving using our solution, Footprint Finder, PCVC, and PCSLC. So I hope you enjoy this webinar. That's me, Jolandi.
Perfect. Thank you, Daniel. If you can switch off your webcam for the duration of your presentation.
I will.
Thank you.
Good day, and welcome to this presentation on strategic and tactical mine planning for caving. To start this webinar, I would like to describe why we believe caving is the future of underground mine industry. First, it's difficult to find great deposit near surface. Second, open pits are operating in deeper conditions, meaning geotechnical challenge, lower productivity, and higher production cost. Then, as an alternative, caving method offered to maintain similar production rate and using the lowest operation costs compared to any other underground method. Also, caving design and its operation allow automation performing well, transforming this type of mine into a rock factory, providing a safer and a more productive alternative. Additionally, there are plenty experience accumulated over the years, including different commodities like copper, gold, iron, molybdenum, and diamond. Finally, its environmental impact is much lower, and as an example, you can see Chuquicamata mine in Chile, where the limit of the open pit is highlighted in white, and this red zone represents the area where the dump were allocated, showing a quite big footprint. If we compare this with the size of the footprint designed to extract by underground is really small, and its effect or impact in the surface is just limited by this circle according to the subsidence created. I would like to take a few minutes to discuss with you on who we are and how we deliver our solution. We have the profound belief that the virtual world extends and improves the real world. In life, there is no rehearsal. In the virtual world, we can simulate and evaluate impacts before producing the product itself. In our company, we are a purpose-driven company. We think of the progress and innovation in terms of balance and impact. We have about 20,000 passionate people from 140 nationalities across the globe. We also have a large R&D team connected across 69 laboratories, and Dassault Systemes has a large PLM and 3D experience market share with more than 270 customers in 11 industries worldwide. We have proven track record that we can make our purpose happen. Industry will not be what it is today without Dassault Systems contribution. We have been the catalyst and enabler of the world's greatest industrial transformation. Every decade, we have helped manufacture to disrupt how products are designed and made. Everything started in 1981 with a 3D design application, then moving to the second stage to the 3D digital mockup, and the third is the product life management to go to the 3D experience to represent what is today. Now, in the near future, we will enter in the fifth stage of this journey, moving from the representation of things to life. 3D experience, it's our platform that is summarized and described with 13 brands according to the distribution of their applications in our compass. For example, 3D application represent how we're going to be modeling three-dimensionally the world, and in that you will find solution that you probably heard or using now, like GEOVIA, Surpac, Whittle, or PCVC for blockade. Moving to VR, represent the virtual and reality, where we have simulation apps to represent what can we do, what can we simulate before this is executed. Information intelligence is where all the data is analyzed and distributed in different format and dashboard. And finally, combined with the social and collaborative apps, where we create an environment of collaboration to link everything inside the 3D experience platform. We serve 11 different industries with tailored industry solutions to address their specific challenge. The strategic and tactical mine planning for caving is an industry process experience where we address how to model and evaluate caving projects. This workflow is made up of 7 business processes. This methodology has been brought into the 3D experience platform, providing full governance of the mine planning process, improved by simulation and analytic of the result, and finally, better collaboration, communication, and visibility to all stakeholders. Let's take a look in detail for the first step in any caving evaluation, specifically in this case, where we take a strategic decision to evaluate where the optimum location for a footprint will be calculated. And not only that, also we can evaluate different options like dividing the structure in 2 lifts or 1 lift, and all that is supported by the economic calculation and the evaluation done directly in the block model using our caving solution called Footprint Finder. For that, we will see this video where you're going to have the opportunity to see how the solutions look like. So we run the options. In this case, you can run one scenario or even multiple scenarios by selecting inputs to read the area of evaluation from the block model, dilution, some economic inputs, and also some specific parameters related to the block caving mine. This input can be read directly from Excel or from an advanced profile. And as you can see in here, this run is showing the evaluation done for every level, where it's possible to see that every column for every block is evaluating, simulating one draw point at a time. The color reflects the economic result. And additionally, a report is generated in Excel when you can easily see the elevation simulated with the tonnage and economic value calculated with additional information like grade. With that, you can easily select what will be the best option to do further analysis and more detailed analysis. For example, limiting a footprint that it's more close to the real condition. So what we're going to do in this case is limiting the footprint and run again on Footprint Finder, but not this time to select what is the optimum. In this case, we're going to be creating a simple production schedule by simply having different inputs as the tonnage profile or the production rate selected and the sequence. In this case, the footprint is being divided in 3 sectors. So this production schedule will follow that. When you run, you can see graphically how the sequence is applied, and also the height of the column will be simulated during the extraction. As you can see here, is very easy and quick to do, so multiple analysis and multiple options can be evaluated. Also, the result, it's dumped into Excel, so easily you can see what is the production profile for different periods with all the grades and detail that you are expecting to have. The next business process is where we're going to be working more in detail and simulating material flow and dilution. In this video, you can see a second solution that's called PCBC, where we're going to be working more in detail, starting with the footprint selected previously. Here is where we can easily generate any layout to distribute draw points inside the footprint selected. By having those draw points, we can create now what we call a slice file to put all the information from the block model in a draw column format. With that, we will be able to use a different mixing mechanism to simulate the extraction and including dilution and the simulation and how the material will be extracting in this case. What you are seeing now, it's an economic calculation where we can define the reserve of this deposit. As you can see, based on the distribution of the grade plus the economic information, easily calculate the tons and grade associated to declare those reserves. With that, we can easily display any information associated, and then we can move in the definition of the production schedule. In this case, you can see how a production schedule, and specifically in this case, will be generated using 2 sectors and 2 different front shapes. Also, more detailed inputs can be added in Excel, like a specific production target. And here, depending of the level of detail that you're working with for a strategic mine planning or tactical, can be divided by year, month, or even weeks if you want it. With that, you have a lot of flexibility and multiple options to do this evaluation and create a production plan that can be used for different purposes. For example, for yearly forecast, quarterly forecast, monthly forecast. In here, you can see as well in Excel all the result and detailed information like tons simulated and the grade associated for the total of the run. And additional information can be also displayed even by draw point, where you can easily visualize what is happening in different formats per draw point per period. For example, in here, you can see what is the height of destruction done at certain period. Moving more into the detail of the analysis, we can use other type of mixing mechanism or mixing algorithm like CI3D, or better say cellular automata. This is a numerical modeling that helps us to have a better level of resolution of the simulation of the mixing that we're doing. In this case, basically, you run directly in the block model, and all the extraction is simulated. What you are seeing in here, there are different rock domain with different physical properties, and those properties will be used during the simulation to see, for example, if this material is expecting to be finer than the rest, is going to be percolating and moving faster than the other. So in this vertical section, you can see how the extraction is simulated, how the material is being mixed and extracted, and in the end, you will see the result dumped into Excel in a similar format as you see it before. With that, you can do not only a visual analysis of the run, also a quantitative analysis, and then you can see all the details of the run. Previous example was done for a block caving project, but our solution also includes sublevel caving as an option. In this video, you can see how a sublevel caving was previously designed and scheduled according to the rules of the sequence and the combination of the extraction to get a production plan. Also, this information can be linked with the development to import all the information created in PCSLC by ring and generate all the data and design in Mindjet. With that, we can combine development and production and not only visualize together, also prepare the development plan to support the production that I wanted to get from those rings. So in here, you can see the same sequence simulated in PCSLC and combining the development and production. The next item that I want to mention today is how we're going to be incorporating geomechanics. And for that, I'm going to use the example and the development done in combination with Newcrest, where we basically integrate geotechnical constraint into the mine planning process. This was done also using our solution combined with iSight or Process Composer, where basically combine different processes in a workflow to connect where you can do typically in PCVC and the estimation of the shape for the K-back during the run. It means for every period, PCVC will be capable to simulate the extraction done in the block model. Then, by the end of the period, that information will be sent to Abacus. And in Abacus, due to the redistribution of the stresses, the next K-backs will be estimated. With that, that information is sent back to PCVC, and PCVC will run the next period. As I said before, all this is done and combined using eyesight, where we can see all the process and simulate different options and different scenarios easily to get the result that we want. Now you're going to be seeing the execution of this solution by basically running the process from eyesight. Eyesight execute internally PCVC and run the production schedule that you are evaluating. In this case, we're using cellular automaton as a mixing model, and that will provide the information and link the data with Abacus. And in Abacus, you will see how the simulation is done, how the stress analysis is simulated according to the sequence used, the extraction done, and all the inputs that we typically use in a production schedule. And most importantly, getting inputs of how the K-back is growing and how the vertical displacement is calculated to, for example, visualize what is the principal stresses and how you're going to be connected to the surface and or breaking through the surface. You can see different concentrations of stresses, and very interesting how the combination or lift 1 and lift 2 is done based on the sequence that you are trying to evaluate. So this is finally where we were dreaming before, connecting mine planning tools or mine planning solution with a geotechnical assessment all at the same time, all done period by period. Now, I would like to take a few minutes to talk about the scenario analysis, because this is something that we were never capable to do it before without the tools inside the 3D Experience platform. For that, we will be using Process Composer or eyesight to basically be able to generate multiple production schedules by changing inputs and even analyzing their optimum combination to find new options, not only the typical approach that we use to take that decision. For any caving project, we have a multiple range of inputs and parameters like economic, mixing, sequence that we would like to test, production rates, commissioning neutral points, and all these are very difficult to combine and see them and simulate them properly. Normally, we just evaluate one or two options and then we made a decision. And that decision will be translated in things like NPV, tonnage and grade, profile. But we couldn't do a proper analysis in terms of variability or robustness. As an example, I would like to describe the same deposit that we were showing you before, where we select one specific extraction level. For that, we did the calculation of the shut-off grade of $15 per tons, and with that, we calculate the reserve. Those reserves were basically 988 million tons. And if we run this case using a production rate of 100,000 tons per day and developing this mine with 12 draw points per month, this provides us this production schedule. And when we calculate the NPV for that is 1.3 billion. However, what's happening if we want to challenge this or even go further and see what would be the opportunity to find a better solution, a better result by let eyesight, in this case, to simulate multiple options, multiple alternatives by changing the shut-off grade, the production rate, and the development rate. As you can see in this graph, iSight is capable to generate different scenarios, and where you are seeing with this square with different colors and different areas are different scenarios simulated. For example, all those grays are valid scenarios and all those red ones are not valid. Why? Here we have different constraints and different options that limit the solution area. With that, we will be capable to simulate more than 100 scenarios, and for that we can highlight number 88 as the best case. For that, you can see that the shut-off grade increased from $15 to $22 per tons. The development rate suggested was going higher. It means developing this mine faster. And interestingly enough, the production rate was reduced not to 100,000 tons per day, to only 78,000 tons per day. With that, the NPV increased by 33%. And not only that, it's also providing a nice profile, similar as we saw before, with all the level of detail and information that we needed. And this is translated in a smaller footprint that we can basically have a different strategy. And all that, it's not only reflected in one value, it's also described in a hill of value. And with that, we can see in 3D shapes or in 2D view, based on the value of the NPV of those scenarios evaluated, where is the best combination of those inputs? For example, the shut-off grade and the production rate. With that, we can challenge the privatization as a base case located basically in this point to go much higher, and in number 33% higher as we calculated before. Now it's time to see how we can bring data and result done in previous steps into the 3D Experience platform. For that, this video will show the 3D Experience platform in action by logging and selecting the application that you would like to use. In this case, we go to the data analysis quadrant. Then we can select what type of information we would like to use. And in here, we have multiple options already developed. For example, bringing data from Footprint Finder or data directly for the run that you do in PCVC. And that combined, for example, with prediction data to compare how was your forecast with actuals. In here, you can see any information that is being generated, for example, in PCVC, like tonnage and grade, and compare those with the actual data collected from the mine. This provides a different level of visualization that can be shared with the rest of the team through the 3D experience, so everyone can have access to this type of dashboard. This provides also a different level of detail depending what you wanted to do. For example, divided for different sectors, different production blocks, or even different mines. Additionally, you can even visualize the information per draw point. So what you are seeing in here, for example, is the ton extracted per draw point, and even the visualization of that data in 2D per draw point. So easily we can understand better where the difference between the actuals and forecasts are done. Or in case you are analyzing different strategy or different options, you can bring it in here and do that analysis. It's very easy to create new options of analysis and new alternative to share this information with the rest of the team. Any data available in the run can be brought into the 3D experience platform. For example, we can easily visualize the status of the draw point. In some cases, highlighting some specific cases like dry or wet for potential wetback or wetback risk, or basically the condition of the draw point, if it's active, if it's planned, if it's permanently closed, or it has some problems like hang up. Additionally, we can manage different level of information. For example, not only per draw point, we can start bringing data from the mine, from the data collected from ore passes, crusher, or even further in this line. Now, what you are seeing in here is an example of the data generated in Footprint Finder. And here is the typical evaluation that we normally do just in Excel, where you can see for different elevation, what is the tons and dollar value calculated, and also the grade for gold and copper. That means the data that you normally see only in Excel can be brought into the 3D Experience platform using the Caving Intelligence app and visualize them in different formats. To finalize this part of the presentation, it's one of the examples that we were evaluating with one specific elevation with different colors. What is, for example, the dollar value, the tons extracted, the height of draw calculated, or the sequence used in that case. We're going to be moving to the last part of the presentation in terms of how we're going to be sharing and collaborating inside the 3D experience. For that, I'll play this video that is also the data that you saw before when we were doing the geotechnical analysis using Abacus. So in here, you can see, first of all, the design of the mine in 3D, and also the analysis of the projection of the cave back shapes. So you can animate it in different periods, you can highlight different information, or you can see what the result of the analysis in terms of, for example, stresses or stress orientation, or any data that you would like to see in this format. So that's another way, another option to use the 3D Experience platform to visualize the data and also analyze and share the information that you are preparing. With that, I would like to thanks for your participation today, and I'm open for questions.
Excellent.
Okay.
Okay, so to our attendees. Oh, you look good, don't you worry.
It's late here, sorry.
Just to let them know, please use the question box to ask your questions there, and Daniel will work through them and answer them for you. We do have a couple of poll questions that we will launch in between the Q&A section, so please do keep a lookout for those on the side, on the right-hand side bar. Daniel, if you find a question there in the meantime, have a read through, and I will launch our first poll while you are looking through that. So our first poll that I'm going to launch for you is, which is the most important KPI during strategic mine planning for your project or operation? Go for it, Daniel.
Okay, well, it's a good, first of all, it's a good question to share with the audience, because it's normally hard to get one consensus where we're going to measure when we are doing the strategic mine planning. So I'm really keen to see what they say. But I do have a questions from that I want to share with you. It's what is the benefit to do multiple iteration for a mine plan? And it's an interesting question, because normally when we are evaluating or running the strategic mine planning project, we tend to do and just take all the inputs that you have, then you just come up with one option or two options or maximum one base case, and then you do some sensitive analysis. In some of the part of the video that you saw a couple minutes ago, I was highlighting the power of doing multiple iteration or evaluating or simulating multiple scenarios. Those are, first of all, it's part of the new technology that we are adding to the caving solution that some of you know already. And it's quite interesting because it's challenging the decision that you're doing. And some of the challenges by iterating more than 100 or even 1,000 options. For that, you can even optimize a solution that you couldn't see before by combining in an optimum way those inputs. In the result that you saw, that it was a real case, or it's a demo project, but it's based on a very realistic model. And I was surprised that after running 100 iteration or after simulating 100 scenario, we learned so much. And that's exactly what we're planning to do in this process, is taking the advantage of multiple simulation, multiple scenario to discover new solution. And from that, analyze the risk and the robustness of the base case that you're taking.
Thanks, Daniel. If you look at those poll answers, you'll see that 60% of the people have actually identified risk from inputs, parameters, or assumptions used as the most important KPI. So, as per what you've been doing, it seems to answer your question there.
No, that's great, because normally we tend to go, for the value. So that's why the NPV, it's appealing and it's attractive, but sometimes doesn't reflect exactly the value of the project or the value of the option that you're taking. So measuring the risk is part of the multiple simulation that you can do.
Yes. All right. So if you would like to find another question to answer for our attendees, what I can do is I can identify the next poll question while you are looking through that. I will launch the next one. So the next question is, perfect. What challenges do you face when maintaining your assets in your operation? I'll launch that, and then Daniel, I'll hand that back over to you.
Perfect. I'm going to use this question from the audience as well. It's basically describing how we can add more details, how the platform helps to create the collaboration and the sharing data. And that's probably one of the most powerful things that we can do, because normally with the solution that we have, all the results are stored in Excel or PDF or just simple data that is, first of all, very difficult to share with all the people, all your stakeholders. Second, you lost visibility of the rest of the data. And how the platform is created is exactly to bring all the data that is being used during a project, even organizing by different tasks, and those tasks can be storing properly the data that you are adding for that specific task. Let's say initially you take the decision about the elevation or the optimum elevation of a footprint. So that task has multiple inputs, multiple assumptions, and also multiple discussions. So all that can be brought into that task and stored properly, and most interesting and important, share with the rest of the team through community, and even bring it data in 3D. It's all available. Okay. Let me see. We have another question here. Is in average, how many man-hours will take to set up something like this? And how do you have an org chart to show the key personnel for development, tech support that we have shown? It's interesting because obviously what we are seeing now it's a combination of multiple solutions. But to highlight, the first point is how many hours take this. This is not just buying a software or implementing this. It's the whole solution that we're aiming for. So that's why it's called the 3D Experience Platform. It's a combination of multiple solutions. We even go to a different aspect of the mining, from the mine to port, going through every single stage. But if we focus only on what we're presenting today in terms of the mine planning, even the mine planning portion, or even the strategic and tactical solution that I was presenting today, has different stages that can be implemented in different periods. And obviously, the amount of hour that is required depends of the level of implementation and also depends of the complexity. So it's, but in general terms, after you implement that and you start comparing, one of the thing that we do initially is to open this conversation through a process that we call value engagement. And that helps us to have in different stages also how to identify the challenge that you're facing, the pain point. And that is something that we do through interview. Then we come up with a map of how the solution or how you're dealing with those challenges now, and then how the 3D experience can help you to work with that. So it's more than just a simple software implementation. Back to you now.
Daniel, I've launched the third poll question, which is how do you track your progress measurement? So that is running at the moment to our attendees. If you can identify another question that you have that you would like to answer for our attendees.
Yes, we have one here. Does the Avagus model include water ingress in the draw point column in order to direct mud rush occurrence? I think it's possible, but not in this case. In this case, it's where we were aiming was to take basically all the information that is available in the block model by different domain, let's say different conditions of the rock type per domain. And with that, according to the changes in the stresses created by the sequence and the extraction that you're planning to do, we were aiming to estimate what is the shape of the cave-back, because that is critical to predict where the material is coming from and where the material will be depleted and reported per draw point. We didn't address the water in this case, but it's possible to do. I will add to that even if we don't use the water as an input directly, it's something that we do use in the mine planning process. And with that, we have different inputs, different conditions of the draw point, and even constraint that can be applied by the time you run the production schedule. And that can be used in different stages of the mine planning process, including, a strategic, long-term, medium-term, the forecast, the monthly predictions, and things like that. And even in a daily cases, we use that as an input to quantify how we can allocate the equipment and the conditions to operate. The equipment to operate in those conditions. With Freeport, we got a lot of experience.
Great, Daniel. Do you have one last question for us as we start to wrap up while I launch our last poll for our attendees? Have a look through and see what you can identify. In the meantime, I'm going to launch the last poll for you. Thank you very much for your participation. With regards to the last question, for those that are interested, 80% of the attendees came through and stated that Excel or PDF reports is what they use to track their progress measurement, and then 60% came through for several siloed software. So that's quite interesting. All right, I'm going to launch the last poll. Which predictive models are applicable in your mine planning process? Daniel, I'll now hand it over to you for the last question to be answered, and then we can wrap up.
Thank you. Before I move to the last question, I wanted to make a comment about the last result, because that's exactly what is happening. Most of the result and most of the information is just stored in files. And those is where we share with our team through emails and presentation, but it's very difficult to find one platform to put them all together and be transparent and even create communities where we can work with our teammates. So that's exactly what the platform is doing. So hopefully we have more time in the future to describe better the powerful options for sharing and collaboration that the platform is bringing. The last question is how the solution combine long-term, medium-term, and short-term planning. I don't have the picture here, but that's something that I use normally in other type of presentation when I have more time, because in reality, our caving solution is a compelling solution. It takes you through the decision that you are making as a strategical decision, like as I mentioned in my presentation, you know, where the best elevation for the footprint will be located. Then take you through into the same solution using the same inputs, using the same information and software. You go from that to the detail of what is the design that you're going to be using, then what is the impact of the distribution of your tunnels, draw points, and then you go to the detail of the mine planning. It means it's all combined and it's all in a cycle. What I mean by that is, for example, if you are running your life of mine plan, you divide that in a year, then you start working more in detail in a monthly forecast. The monthly forecast, it's also take it as a, for the next month, for example, is taken as a target for your daily operation. After the month is done, you reconcile the result, and then you know how many tons were extracted for every single draw point in that month. Then you can do a compliance analysis to see what is the deviation of your plan versus the actual, and what is the reason behind. After that, you can easily import the actual data and import the conditions of the mine to update the forecast for the next month and so on. And then by the end of the year, you get the summary for the annual reserve, and you update the whole thing. So it's a cycle that is well connected. It's a compelling solution, and it's all based on the same solution. And the best now is we are bringing that information again into the platform, as you saw in the video with the cave intelligence. So we hope to do more in the future, and that's part of the whole platform.
Lovely. Thanks, Daniel. I don't know if you would like to wrap up with the answers from the poll question there.
Sure, if you can help me to.
Sure. So the question was, which predictive models are applicable in your mine planning process? 58% of our attendees came through with reduce unplanned events. 50% came through with maximize equipment utilization, and 25% came through with improve safety.
Mm-hmm. That's very interesting, because those are not exactly what I was expecting. But
no, what were you expecting?
I thought reducing or increasing or improving the safety condition will be one of the top. But
okay.
But also it's interesting because the utilization or the utilization of equipment are high, and I forgot the first one.
Reduce unplanned events.
Yes. So
yeah.
For reducing unplanned event, that's interesting, because this is all related to in the way that we can simulate multiple events or add multiple constraints in the mine planning process. And that is something that we were doing quite well before with PCBC, but now enhancing that solution by running with other solutions like a Process Composer or ISA to run 100 or 1,000 scenarios in a short time. It provides that. It helps you to highlight, the decision that you're making to use a specific sequence is the best, or that can create some issues, or put you, if you remember that hill of value graph, it's put you in a spike that can be good, but quite risky at the time that one of the input change, one of the parameters change, is going to put you in a very difficult position, or in a different position with a lower value, or highlighting the risk that you're trying to measure. So by simulating multiple cases, you will learn a lot from that, and then you can react over that. And that includes equipment. Equipment, we can translate how we can maximize the utilization of the equipment by learning what is happening in the mine, learning what is happening with those equipment, and applying those constraints back into the model. That is also part of the future plan that we're aiming for. It's part of the caving intelligence that we're dreaming about it, and now it's a reality that we can do with the 3D Experience platform.
Lovely. Well, thank you very much. And thank you to you, Daniel. What a great presentation. Thank you to everyone for joining us and for your participation. Upon closing this webinar, we have a short survey we ask for you to complete. So please do stay connected. The survey will pop up once I've ended the webinar. Thank you again and have a lovely day further. Bye.
Thanks a lot.
Bye, Daniel.